we come on to how this device is working. Now, I've looked at the Bedini motor. Now, the Bedini motor, there are people who have measured whether the Bedini motor is getting energy from somewhere, and it appears to be that way. Now, the Bedini motor has two coils, one which pushes a wheel around, and the other one which charges a battery. Now, Stan Myers believed that the excess energy in his device was being tapped from between the plates, that there was something in the water, that was some resonant frequency of water, which made the water molecule split much easier. Now, I'm not sure he's correct there. I actually think that the excess energy is possibly coming from the two coils either side of the electrodes. And the reason why I come to that conclusion is because of the Bedini motor. Because the Bedini motor is another over unity device where the excess energy appears to be coming from the electrical coil when its field collapses. So a certain amount of energy is put into the coil to magnetize it, to create the magnetic field. That is then switched. The field collapses, but it appears to be dragging more energy from that collapsing field into the battery in the Bedini motor. So I think where the energy is coming from in some of these over unity devices is in a collapsing magnetic field from an inductor, but it's how you capture that. So the Bedini motor, it's been used to charge a battery, and I think in the Myers device you've got these two coils either side of your. I think the excess energy is being used to crack water. Alright, so, but I'm open to a debate on that. In the Myers circuit, you have he had some electronics using 555 timers and that kind of thing to generate these various pulses. I'm actually using just a personal computer, and I've got it connected to I've got a digital output connected to the parallel port, which is driving an optocoupler which switches the thyristor on and off however I want it to. There's some software I've written on this PC. It's running on a DOS platform. It's Turbo C, which allows me, this is my control screen, I can generate those pulses anything up to 80 kilohertz, that's 80,000 times a second pulses. They drive the thyristor, which is inside here. The output from that is run through these two coils into the cell and back around. Now, so let's just demonstrate that. So we've got mains coming in now. We turn the voltage up, so let's put it up to 70 volts. If I hit the number 1 key, that will start the pulses, so the thyristor will trigger and we'll get something on the scope. You see there, so this is the voltage signal across the actual cell, and see the current's pretty low here, but occasionally what I've noticed what happens is you increase the voltage and suddenly the current will go right up, and you'll get more gases coming off. I've not had huge amounts of gas, certainly not over unity. You can hear the thyristor switching. What I'm going to do now, I'm just going to show you the inside of this box, and then once I've done that, we're going to try and film some gases coming off. Alright, so this is our variable transformer, which just goes through a bridge rectifier. The output from the bridge rectifier feeds the voltmeter. It also feeds the thyristor. So here's our thyristor here. The output from the thyristor, you can see there it's got a diode, a reverse diode across it. There's also, this is the blocking diode here. We've also got some protection on the input voltage, which we've got, I think it's a 5 amp trip, which is up in the front there, which is this thing here. I can actually press it, so that thing should pop out if the whole thing draws more than 5 amps, just a safety device. So our optocouplers well, that one there is not used. This is the optocoupler, which is connected to the computer. So the signals from the PC's parallel port come in here. So that's just I think it might be 5 volts. So they come in, they're wired into one end of the optocoupler, and then the other end of the optocoupler triggers the gate on the thyristor. What the current from the thyristor then goes through this diode and then through the ammeter, which is in the front panel here, and then when it then comes out the front panel. I did have a coil inside, but this is redundant now. That coil is not used. This is the coil here, which I've wound myself. There's a bifilar coil. In other words, there's actually 2 coils wound on the same core, and this apparently is one of the important things of the Myers device. So the current comes out, it goes well, it's through this copper wire here, through the coil, across the cell, and then back down. Now there's some debate over whether you wire the 2 coils in opposition or supporting each other. In other words, so that the fields are aligned. Now I've got them supporting each other. I've researched quite a bit of stuff on the internet, and I don't think you wire them such that the magnetic field in and out are against each other. I think that you have to do it so that they're supporting each other. We can have in this Tesco coffee jar, we can have a second cell in there, but I'm just using one at the moment. We've got an amp going through there now, 100 volts. We've got gases coming off there. Right, so we can see there we've got the voltage is 100 volts. We've got just under 2 amps, so we're just under 200 watts. And you can see there's quite a lot of gas coming off. Now it would be a question collecting that gas and measuring the volume and ask, well, is it higher than the 200 watts? Now, I'm not sure whether our pulses are triggering this thyristor correctly, because you see the scope there, it's only been triggered once every mains cycle, and it should be, if you look at the Myers literature, they're triggering much faster than that. So I think there's a problem with the triggering, but that's just to demonstrate there that we've got hydrogen and oxygen coming off there. But skeptics would say that hydrogen and oxygen is just a result of bog standard electrolysis for the energy that's going in, but I wouldn't know until I've measured it. You see that the current there, in my opinion, is too high. That needs to be limited in some way, but in a way that the gas still comes off, and this is what this current sensor circuit is going to do. Now I've got this rig set up and I can generate small amounts of hydrogen and oxygen. The thing then to do is to modify various sections of it in order to try and get more yield of gases. Now, one of the things that I've decided to put in is to add a current sensor on the main wire going through the cell, and then put it through a comparator so that you then feed that signal back into the computer. So in other words, once the current gets above a certain level, the computer knows that and then can switch off the output pulses. Because the whole intention of this design is to try and limit the current and get the voltage as high as you can. But as my understanding, as soon as the water is cracked, the current increases and you need to back off. So what I'm going to do is, as I say, put a current sensor in there, and then so the computer knows as soon as the current is above a particular threshold value, it will cease firing pulses and turn the thyristor off and stop any current flowing. So that's one modification I've yet to do. The other enhancement is to try and decrease the air gap, or so it's not an air gap, decrease the water gap in the. So what I've actually done, I've bought a slightly different wall thickness tube. Right, so I'm just on my way to a little engineering company who I've asked to weld this M6 threaded bar onto this stainless steel tube. So they've just got to fix it like that. Here we are, it's Rokel Engineering. Right, I got two of these made. As you can see, they've made a good job of the weld, and charged me 10 quid for the two. And that will reduce the gap down to 0.9 of a millimetre, which is a fair bit less than it is now. So that should increase the amount of volts per centimetre, therefore encouraging the electrolysis. So there's all kinds of, I mean, you can modify the pulse widths, the frequencies. There's all kinds of things we can play around with here in order to try and achieve what Myers did.